Okay, so this video, this is a continuation of section 5.5. This is probably 5.5B for Hawks. This section is a lot. So I'm going to try to go through it and talk about the things that I think will actually be helpful and skip over the stuff that's really math heavy and maybe not all that helpful. So the elasticity of demand, and I don't know, this may be a thing you've already talked about in your business classes and stuff, but this is new to me. This is a math application that I was unfamiliar with until I taught business calculus. So, but maybe it is something that you guys know. But the elasticity of demand, this basically is how price, demand, and revenue are related. So when price goes up, demand goes down. Obviously, the more expensive something is, the less people want it. When demand goes up, the price should go down. So this is like how that works. And the thing to ask is what happens to the revenue in each case. And basically this depends, like, are they making more money or are they not? And it depends on how much the demand changes. And that is what elasticity of demand is. It's going to be like a measure for that. So I think this example is confusing, so we're going to skip it. But the like questions here, or this concept. So for determining the effect of changing the price or demand is called the elasticity of demand, and it's found by looking at the relative change in demand. So how big is the demand changing, and that's going to help us figure out how much is the demand changing. That'll help us figure out what's going on with the revenue. So if you increase the price and the change in demand is relatively small, so price goes up and the change in demand doesn't really do anything, then revenue should increase because you're charging more and there are not fewer people buying it. If you increase the price and the demand is the change in demand is relatively large, then the revenue is going to decrease. So, and this again happens because as price goes up, demand goes down. So if you have a really big decrease in demand after you raise it, then you're going to lose revenue. But if your change in demand is relatively small after you increase the price, then you're not going to lose revenue. You'll actually earn money. So that's the whole idea here. Those two bullet points are basically what we're doing. So we can quantify this by comparing the relative change in demand to the relative change in price. So what's happening as we change price, what's happening to the change in demand. And so if you put those, if you divide those to get this sort of ratio happening, this is the percent change in quantity. And then the stuff down here at the bottom, the delta P over P, that's the percent change in price. And so if you look at that in price, if you look at that, that setup, you end up with this sort of thing over here, P times delta X over delta P over X. And if you took a limit as delta P goes to 0, there's some math that happens here, and you're going to get -1 over X dx over d prime of X, and that's your demand function. And then the top of the next page is going to put this in a way that we can actually use it for our applications. So if X equals F of P is the demand function, that's our d of X, is for a certain product, then the elasticity of demand for that product is E, which is given by -P times F prime of P over F of P. So that's the thing that we're going to look at, -P times F prime of P over F of P. So if that E is greater than 1, then the demand is elastic. If it's less than 1, then the demand is inelastic. And if E, the elasticity of demand equals 1, then we say that the demand has unit elasticity. So if the demand is elastic, what's happening to the revenue? So price is increasing, revenue decreases. This means price is increasing by a lot and demand changes by a lot. The demand is changing a lot. That means it's elastic, so revenue is going to go down. If demand is not changing that much, demand is staying steady, then the revenue is going to go up when the price goes up. This is sort of the like parenthetical thing here. So if the demand is elastic, that means the demand is changing a lot, which means as price increases, the demand is going to decrease, which means revenue will decrease. If the demand is inelastic, that means that the demand is not changing, which would mean as you increase the price, then the revenue also increases. Okay, so and then so price increases. Goodness. So the way that I try to remember this is the ends. So increases, revenue increases, and this is inelastic. So those all go together. Elastic, that means price increases and revenue decreases. Okay. And then for the unit elasticity, what's happening to revenue? The revenue has been maximized. So you've reached that point where changing the price and changing the demand gives you that maximum revenue. Increasing price more would make the revenue go down. That's what's happened there. You've got the sweet spot. Okay. So let's do some examples here. We have this X is F of P. This is our demand. So 1875 minus P squared. And for these following values of P, determine whether demand is elastic, inelastic, or has unit elasticity. And then how does an increase in price affect the revenue? Okay, so E is equal to P times F prime of P divided by F of P. That's it's negative P. F prime of P, F of P. So here that would be negative 15 times F prime of P. I'm going to do this in a different color up here so we can see it. All right, so F prime of P is negative 2P. So here we have negative 2 times 15 divided by 1875 minus 15 squared. Maybe I should write this down differently here. Let me do this. The elasticity of demand is going to be negative P times F prime of P over F of P. So for us, that is negative P times negative 2P over 1875 minus P squared. So this is our E, and we're going to do this a couple times. Let me erase this. So when P is 15, we're looking at E is negative 15 times negative 2 times 15. Over 1875 minus 15 squared, which is going to be 450 over 1650, which is less than 1. So that would be inelastic, less than 1, that is inelastic. E is less than 1, so it's inelastic. So as price increases, The demand isn't changing much because it is inelastic. So that means the revenue will increase. Okay. Then when P is 25, we have E equals negative 25 times negative 2 times 25 divided by 1875 divided by or minus 25 squared, which is 1250 over 1250. Ooh. So E equals 1. So this is unit elasticity. So revenue is maximized. Okay. All right, and then for P equals 40, purple, purple. We're looking at E is negative 40 times negative 2 times 40 divided by 1875 minus 40 squared, which is 3,200 over 275. So that is going to be bigger than 1. So it's elastic. E is bigger than 1, which means it's elastic. So as price increases, demand is changing a lot, which means it's going to go down, which means that revenue will go down. Okay. So there you have an example where we get something that's inelastic, which means as revenue increases, the demand is not changing that much, which means that as the price increases, the demand does not change very much. It's inelastic, so the revenue will increase. When P is 25, we have maximized the revenue because we have unit elasticity. So changing the price will, we're at that sweet spot. We're changing price and revenue. And then P equals 40, we're in elastic situation. So if you change the price a little bit, it's going to change the demand a lot, and therefore the revenue will decrease because as price goes up, demand goes down. Okay, let's do another one. So on this one, we were looking at this function as f of p, x equals something in terms of p. So we're going to have to do that to start with here. So we're going to rewrite this as x equals something in terms of p. So the first thing is we're going to get that p to the other side. So we're looking at 0.01x equals 50 minus p. And then we're going to divide by 0.01. So x is 50 minus p divided by 0.01. And that's what we're going to go with. We could even rewrite this as, what, 5,000 minus 100p. That's what that would be if you put those fractions in a calculator. 5,000 minus 100p. That is our x. Oh, I should save this for right here. Okay. So there is our f of p. And so this is f of p. So elasticity of demand E is going to be negative p times f prime of p over f of p. So we have negative p times f prime of p, which would just be negative 100 here, divided by f of p, so 5,000 minus 100p. So you could simplify this to just 100p over 5,000 minus 100p. What is E of 10? We'll be looking at 100 times 10 over 5,000 minus 100 times 10. And that is 1,000 divided by 4,000. So that's 1/4, which is smaller than 1. So this is inelastic. So that means when price increases, revenue demand does not change because it's inelastic. So that means that revenue will increase as well. Okay, what is the elasticity of demand when P is 45? So then we're looking at E of 45. So we have 100 times 45 divided by 5,000 minus 100 times 45. This is 4,500 divided by 500 or so, which is 9, which is bigger than 1. So this is elastic. So as price increases, demand changes a lot. Which means that the revenue, because demand will decrease as the price increases, that means that the revenue will also decrease. Okay. Let's keep going with a couple more examples. So number 3, we have this price demand equation. Again, that is not in terms of P, it's not an F of P thing. We're gonna have to make it be that. So we'll have 0.025x equals 50 minus P. Still trying to get X by itself. So we're gonna divide by 0.025. So we are looking at 50 over 0.025 is 2,000. And then 1 over 0.025 is 40 P. This is just do this in a calculator. Split this up, 50 over 0.025 minus P over, so put in your calculator 1 over 0.025 and you'll get that 40 P. Okay. So we express the revenue as a function of the price. Okay, revenue, remember, is X times P. So we're looking at 2,000 minus 40 P, that's X, times P. So this is 2,000 P minus 40 P squared. Okay, and then elasticity of demand is negative P times F prime of P over F of P. So we're looking at negative P times F prime of P. This is F prime of P up here. So that would be negative 40 divided by F of P, so 2,000 minus 40 P. All right, and then the question is, it doesn't give us specific values for P to try, but just for what values of P is demand elastic or inelastic. So we want to know when is E greater than 1, that would be elastic, and when is E less than 1, because that would be inelastic. So we're going to take this function that we have, which is equal to 40P over 2,000 minus 40P. We're going to take that function, we're going to set it equal to 1, because we want to know where unit elasticity happens, right? So set this equal to 1 and change colors here. So we have 1 equals 40P over 2,000 minus 40P. Multiply both sides by that bottom thing, and you get 2,000 minus 40P equals 40P. So then we're looking at 2,000 equals 80P. And then divide by 80 on both sides, and you get P is 25. This is when we get unit elasticity. So we want to know what's happening around there. So when P is 25, that is where unit elasticity happens. That's when E is 1. So what's going on elsewhere? If we plug in, like, let's test a point. We plug in 1 or 26 into E. When we plug in 1, we would get 40 over 2000 minus 40, which is 1960 or so. So that would be less than 1. So we get less than 1 over here. And if we do E of 26, I haven't done that, but you would get something that's bigger than 1. So we have, it is, let me get a final answer color here. Final answer. If P is less than 25, it is inelastic because E is less than 1. Elastic. If P is greater than 25, it is elastic. This is inelastic, and this would be elastic because the elasticity of demand is greater than 1. Okay, for which values of P is revenue increasing and which values of P is it decreasing? So when it is inelastic, when price goes up, when price increases, revenue increases. So when P is greater than inelastic, when P is less than 25, that is when the revenue would be increasing, which makes sense. You're increasing until you get to this elasticity of demand maximum and then back down. So elastic, when price increases, revenue decreases, and that happens when P is greater than 25. Okay, we can do this last one maybe, and then I'll leave the rest of those for you guys to try and let me know if you need any help with them. But let's work this last one. So suppose the demand function for a product is given by this. What's the price per unit if 50 units are sold? Demand revenue is X times P. So we would be looking at X times 300 minus 2X. So 300X minus 2X squared. Revenue at 50 units is 300 times 50 minus 2 times 50 squared. I need a calculator. $300 times 50 minus 2 times 50 squared. 10,000. So the price per unit would be 10,000 divided by 50, which is something I should know. Oh my goodness gracious. $200. Find the elasticity of demand function. So we want to get f of P again. So we need to do that first. So P is 300 minus 2X. So P minus 300 divided by -2 would be X. Or you could say X equals negative P plus 300 divided by 2. So, oh, this asks for E of X. Is that a typo? Yeah, then it asks for what quantity of X maximizes revenue. So we could actually figure this out anyway. What quantity of X maximizes the revenue? Revenue is 300, 300X minus 2X squared. So R prime would be 300 minus 4X. That has a 0. Is that 150? 75? 75, of course, because 150 would be 2. X is 75. And then you would be looking at some test values. This would be an R prime number line. Test, I don't know, 70 and 80 into R prime. So 300 minus 4 times 70 is 20. So that's positive. 300 minus 4 times 80 would be negative. That's negative 20. Oh. So increasing into the thing and decreasing away, you get your maximum at X equals 75. I am going to leave these because I am not entirely sure why we're doing E of X there and not E of P. So if I see that come up on the Hawks homework, or if you guys do, send me an email and I will work this one for you in a video. But yeah, hopefully we would get that to be happening, that this would be inelastic at 50, because we are going to max out our revenue at 75. So we should get inelastic at 50, and then it should be elastic at 110, because that would be past the point of where increasing price no longer increases revenue. It would decrease the revenue at that point. So let me know if you have any questions about that stuff. Try some problems and send me an email if you need some more help. Thank you very much.